Hello all. Today we are solving LeetCode problem number 2751, robot collisions. So this is a hard problem. So let me read out the problem and then we can jump into the observation and coding part. So there are n one index robot, each having a position on a line and health and movement direction. So you are given zero indexed integer array named positions, health and string directions. So in directions it is either left or right. So all the positions are unique. So all robots starts moving in the line simultaneously at the same speed in the given direction. If two robots ever share same position while moving, they will collide. Okay, so if it is opposite direction, it will collide. If it is in same direction, it will not collide. You know how the rule of collision, right? So yeah, so if two robots collide, the robot with lower health is removed. So this is the observation part. So the two robots collide, the robot with lower health will be removed from the line and health of the other robot is decreased by 1. The surviving robot continues in same direction as it was going. If both robots have same health, both will be removed from the line. So you have faced condition 1. If uh, two robots, let that can be robot 1 and robot 2. So if for robot 1 we can have it as health 1, so if health 1 is greater than health 2, you will remove you will decrease the health 1 by 1 and remove robot 2. So this is 1, and the second one is if robot 1 is equal to robot 2, or the mainly the health actually. So h1 is equal to h2, remove both. So this is the thing, and your task is to determine the health of robots that survive. So in the end of operations, if any robot survives, you have to return the health actually. So in the same order of robots, so this order should be preserved, that is given, and final health of the robot of 1 if survived, if robot 2 if survived. Okay, whatever robot is survived, we have to return the health in the array format. So that is what they have given, return an array containing health of remaining robots. So this is all about the question. So this is not exactly the hard problem, it is very simple to understand actually. So main thing is you have to understand these condition, and you are given these three arrays actually: positions, health and directions. So you have to use these three arrays and then construct robot line and then apply conditions. So this is the idea behind solving this problem. So first let us understand how do we construct this. By constructing, I mean here is we are given all these information, but these positions is respective to robot at index position I, right? And this health is also corresponds to the index position I, right? So based on the robots we are having these values, so we can zip it and create a nested array. So that array will contain, for example, at robot I, it will have the health of the first it will have the position, that is position, then health, then direction, right? So main thing here is to track all these things in order. We have to have index in place actually. So based on index only we will be able to locate the position actually, or we will be able to place the robot. So that is so important here, because in the end we have to return in the order, right? Order if that were given in the input. So in that way you have to track it down, so you will have the index created. So this will be the values with which you will store each robot values actually, so in the form of nested array. So with that you can construct the robot line. So next thing is for handling the collision part actually. So that is so simple because that is very similar to the parenthesis problem which we have deal with the help of stack, the open and close, right? So open and close brackets. So here we can consider this as open as right and this closed as left. So whenever you have the direction as right, you push into the stack. So whenever you encounter anything in the left direction, what you will do is collision will happen at that position. So right, so you will compare the top of stack with the current, that is the left with left, right? So whichever robot survives, you append to stack. Survive robot you append to stack, the other one you pop it, right? So pop the collided robot, and you repeat this process till completing all till processing all the nested arrays, and you will have the the stack being filled with the robots. So when that is done, you will return all the health from the stack formed, right? So this is the idea with which we are going to solve this particular problem. So till now this will be a little bit confusing, but hold on with me, let us run through the example and then we can understand this problem. We will be having a dry run over it, and the coding part will be very simple with the help of that particular part. So based on this example here, it is given completely right. So it's very simple actually. So first thing is you have to construct by using zip, right? And you have to construct a index also. So what we do is we will take these all values and construct the zip value. So with that we will have it, name it as bot, and bot will be equal to, you will have the nested array. So we will have position as 5 and 2, then it is r, and this will be 0, right? So this is 1, and the next row will be placed in 4 17 r1. Next is 3 9 and r2, followed by 2, this is 15, then r and 3. The next row is what do we have, 1 10 r and 4. So these are all the robots which is being formed, and now we iterate through the bot, right? Through this bot we iterate, and now we check if direction is equal to right, then what we do is append to a stack all the values you append into the stack. So which means you will append 4 17, then what else is there, then r and 2 you append into the stack, right? If it is direction is equal to left, then what happens here is collision happens here. So right now, for this particular problem, it is right. So you will have every values append into this particular stack. So the stack will be same as this value. So the bot will be the same stack value, or the stack will be the same value of bot, which we have given as the input, or no, which we have formed as an input to pass it into this or process into the stack, right? So using which the process is done. So since it is all right, you have appended everything, every value into the stack, and now what we do is we sort the stack based on index. So based on this we sorted. So this is 0 1 2 3 4, so it's already in order. And now we pick up the the direction, actually, I mean not direction, that is health. So we return the health 2 17 9 15 and 10. So this is the output. So that is what exactly they have written here as the output. So for this particular problem, let us consider the direction to be different. Let this be, if this is right, this is also right, this, let this be left and left, the last two value be left and left. So in that case, let me edit it to left and left, right? So now here comes the actual operations. So now if it is left, we see top of stack. By the help of stack of -1, you get the top element, and to access the health you have to use 0 1 2 and 3. So health is at first position, so this will be 1. So using this you will compare with the actual health which you fetched from the bot, so which will be in the name of health. So you use this to compare with the health, actually health which is fetched by the current element. So now so this is the comparison. So you have three comparison here, that is, if health is greater than stack of top 1, then what happens is health will be decrement by 1, and this will become 0. So stack of 1 will become 0, or we pop. So this is the operation which we are going to do. And if stack of tops at index position, the health is greater than health or health of the current element, then what happens is you reduce the health of this value by 1, actually. So this will be decrement by 1, oops, by 1. So now this is done, we have to update health equal to 0. So this value is updated, so this is also done. So if both are equal, then we make both to be 0. So which means 0 is nothing but just the removal of that particular robot from the line, actually. So this is the actual condition, right? So now let us build the stack. So based on that particular question, you will put first 3 values into the stack, right? So imagine this as the stack. So we will append what are the values here: 5 to R, 5 to R, and 0. So this is the first element, and 4 17 R and 1, 3 9 R and 2. So these values are appended into the stack. Then what happens is we encounter the left value. So let me take another color. So 2, oops, this is 215 L3. and you have 110 L4. So now you have to compare the health. So this is greater. What happens is this will be popped out and this will be reduced by 1, so which means this is getting updated to 14. So now again what happens is we see the next one, which is this, and it is in left position, so there will be no collision again. So that is that is how we check. And what happens is, since there will be no collision, so what we return is this is removed, right? So we return to 17, 14 and 10. So this will be the output, and this is what we are going to return as the health output, health array, right? So this is the idea and logic behind how we will be approaching and solving this particular problem. And say time complexity for this will be big order of big O of n log n times, because we are using sorting function, sorting based on the index. So hence also we are iterating n times or n elements actually, so that is why it is big O of n log n. So with this idea, let us go ahead and code this up. So for this problem we have to start with building the zipping the complete positions, health and directions with the index. So we start with bots is equal to, we will zip it actually, so zip of positions, then healths and directions along with index, so range, length, positions. So now we have zipped it, so we have to sort it. So I'll be using a sorted function. So ordered, yes, sorted, and using zip we are constructing this array. So now this is done, we have to create a stack. So stack empty stack, and now we have to iterate. So for positions and health, then directions and index in bots. Yeah, so for these things in bots, so now we have to check if the direction is right, then we directly append into the stack, right? Else what we do is else there is something, we check if there is something within the stack, the similar parenthesis one, right? So now if direction is equal to right, then we append. So dot append, we append all these things. So in the list we append positions, health, directions and index. So we append these things within the stack, and then for else part we will check if something is, we will check if something is within the stack. So if there is something, while stack, and if the top element is equal to r, then we do the operations, right? And we also check if the health is greater than 0. So because we are reducing it, so if we have to check, we have to validate to do the operations, actually the collisions operations. So now stack of and we will be using the health. So yes, so this sorry, this is directions actually. So is r and health is greater than 0. So this is the validation, and yes, so now we move into the checks. So if stack of -1 and 1, so which indicates the health, so if it is less than the health, the current health, then what happens is we decrement health by 1, right? And we pop the element, right? So stack dot pop. So now this part is done. So now we are checking the equal part. So if the health of this the bot in the stack and the current bot, if it is same, we will be removing both. So that's why we will be making the health to 0 and we will be popping. So lf stack of -1 and 1 is equal to health. Health, then we will be making health to be 0 and stack dot pop. So both are removed, and now comes the else part. So where we are decrementing the bot's health in the stack by 1, right? So stack of -1 and 1 is decremented by 1, right? So and we health updation, so health will be 0. So now these parts are done. So we will be coming out of this while loop, and we will be checking if the health is greater than 0, because if there is nothing in the stack, right, so we have to append the value. So if health is greater than 0, what happens here is stack dot append, we append the array. If nothing is there, we have to append something. So in that case, we checking health and then we are appending it, right? So we have coming out of the loop where we are sorting by the index. So now we will start by sorting the index. So stack sort key is equal to lambda. We are using lambda function x such that x of this is 0 1 2 3. So by an index it is 3, so it's outside the loop. Yeah, so we have sorted, and now we have to form the health array. So return health for, and the second one is health, and we have directions and index in stack. So now this should work. Yes, and let us submit it. And there you go. Thank you.